A white hole is considered to be the counterpart of a black hole, but its existence has not actually been confirmed. If it did exist, what would happen? Also, what exactly is a white hole? In this article, we will introduce what happens when a white hole exists. First of all, a black hole is a celestial body with extremely strong gravity, from which not even light can escape. Black holes are difficult to observe directly because they not only do not emit light at all, but also do not reflect it. At the center of this is a singularity with an infinite density, and around it is a self-proclaimed flat surface that you can never leave once you fall into it, and which cannot be observed from the outside. Black holes are celestial bodies so strange that it is hard for humans to imagine them. In fact, the same was true for scientists in the past, and for a long time, black holes were only a theoretical existence. Albert Einstein's theory of general relativity, published in 1915, was a groundbreaking theory of gravity, and it describes the state of gravity in mathematical terms. In response to this, physicist Karl Schwarzschild derived a solution to the equation under certain specific conditions and found that black holes could exist mathematically. In 2019, humanity succeeded in directly photographing a black hole, confirming its existence. So, what kind of celestial body is the white hole, the theme of this article? In fact, the mathematical formula that Karl Schwarzschild used to demonstrate the existence of black holes has two corresponding solutions. One is a black hole. The other is called the white hole. The white hole has many aspects that contrast with the black hole. A black hole is a place where things that enter it can never leave. In contrast, in the case of a white hole, things that are outside it can never enter. But, is it possible for such celestial bodies to exist? Most scientists believe that white holes are merely an existence of calculations and do not exist in reality. As for the interpretation of the mathematical formula, since general relativity does not distinguish between the directions of time, the mainstream view is that a white hole is a black hole that has reversed time. If a white hole actually exists and evidence of it is discovered, humanity will receive two main benefits. The first is that our understanding of physics will advance dramatically. Secondly, it could be the trigger for a method of travel that exceeds the speed of light. Modern physics understands the universe through two main theories. The first is the theory of general relativity, which explains extremely large things such as celestial bodies and space-time. The second is quantum mechanics, which explains extremely small things such as elementary particles. Although these two theories are excellent theories that can accurately predict many phenomena, they have the weakness of being fundamentally incompatible with each other. For example, according to the theory of general relativity, matter has the ability to distort space-time, but according to quantum mechanics, elementary particles, which are matter, are treated as having multiple positions. In that case, there must be multiple starting points for the distortion of spacetime by elementary particles, but general relativity theory cannot handle such a thing at all. Normally, this would be a negligible effect, but there are celestial bodies for which this effect cannot be ignored. That is a black hole. I mentioned earlier that there is a singularity at the center of a black hole with infinite density, but this is just a theoretical calculation. Most scientists believe that a new theory that combines general relativity and quantum mechanics will allow us to describe more accurately. According to quantum mechanics, even if you were to break down an object into its subatomic particles, in theory you should be able to perfectly recreate the original object by examining the properties of the subatomic particles. However, if the object is sucked into a black hole, it will no longer be possible to observe the information of the elementary particles. And because black holes evaporate over a long period of time, any information about objects that fall into them is completely lost. On the other hand, if a white hole exists, a wormhole connecting the black hole and white hole is formed, and there is a theory that objects that fall into a black hole are emitted from the white hole, so it is said that information is not lost. At present, we can only discuss it theoretically because we cannot confirm it with observation results, but by observing a white hole, we may be able to complete the perfect theory in physics known as the theory of everything. Furthermore, if the existence of a wormhole connecting a black hole and a white hole is confirmed, it will theoretically be possible to travel between separate locations in space faster than light. Calculations show that this wormhole is extremely unstable, but after overcoming many difficulties, humanity may be able to achieve super high-speed flight. However, the possibility of a white hole existing is extremely low. This is because it is thought that there is no phenomenon that actually forms a white hole, or that contradicts the laws that form the basis of thermodynamics. On the other hand, as I mentioned earlier, reality is more reliable than any theory or calculation. Just as was the case with black holes, if an astronomical object is observed that can only be explained by a white hole, the theory will be rewritten. What lies beyond that, the physics, the rapid development of human space exploration, and the observations that will trigger it, will they be carried out one day?